For this video, we are going to start at the front of the eye, also known as the anterior segment. The white part of the eye that we see is called the sclera. It is a tough, fibrous protective layer and allows the extraocular muscles to attach to it so that we can have eye movement. This surrounds the entire part of the eye. In the front of the eye is the cornea. It is made up of a transparent tissue, and its curvature provides major refraction as the light and other stimulus are guided through to the pupil. As my 7-year-old daughter said, it's like a contact that everybody has. The pupil is what I find interesting. It is an actual hole in our eye. This lies right behind the cornea and appears black because of the lack of light beyond it in the cavity of the eye. The pupil is where the light passes through on its way to the retina. Before the light can get to the retina, it must go through the lens that changes its curvature so that it can act as a secondary refraction point. When viewing an object at a close distance, the ciliary muscles that we will look at in a minute contract, making the lens look thicker to increase its power. Therefore, when viewing objects at a distance, the ciliary muscles relax, allowing the lens to thin out. The lens sits right behind the iris. The iris is the colored part of the eye that we see that surrounds the pupil. It has the important job of increasing or decreasing the amount of light that enters through the pupil by either enlarging or minimizing the size of the pupil. Also found in the anterior segment of the eye is a watery fluid that fills this part of the eye. This fluid is known as the aqueous humor and provides some nutrition to some of the foremost parts of the eye. Just below the lens, here is a suspensory ligament. These are thin fibers that connect the ciliary muscles to the lens above. So below the suspensory ligament is the ciliary body. This is the muscle that causes the lens to change shape, that allows the eye to focus. Again, these muscles contract, thickening the lens to see at close distance, or relax to allow us to see objects at a distance. The trabecular meshwork is found at the base of the iris and acts as a filter for the aqueous fluid before it enters the vessels here. This part of the eye is my favorite to say. Named after the German anatomist Friedrich Schlemm, the canal of Schlemm is a vessel that takes the aqueous humor to the venous system of the body. Next, we have the conjunctiva. This is a clear, thin membrane that protects the front part of the sclera and the innermost part of the eyelids. Finally, we have the ora serrata. Here, the retina ends and the choroid layer can be seen. This takes us to the posterior segment of the eye, or the back part of the eye. The choroid lies between the sclera and the retina and contains mainly blood vessels that supply the retina with nourishment. The retina is the inner lining of the eye. I think it is probably the most important because here is where the processing of the refracted light begins. The retina contains rods that are responsible for night vision and global movement, and cones that provide color and detailed vision. The cones are concentrated in the macular region. Here, and these photoreceptors provide high visual acuity. The highest concentration of these cones is in the fovea centralis. It is the center point of the macula, and it is only here that we have 20/20 vision. The vitreous humor is another clear fluid. However, it is thicker. It is a thicker jelly-like substance compared to the aqueous humor. It is found in the posterior segment of the eye behind the lens. Right here is the optic disc. This is at the point of entry to the optic nerve. This raised disc on the retina contains no visual receptors, therefore creating a blind spot. Here, the optic nerve contains fibers that relay the vision-related impulses produced in the retina to the brain for processing, letting us understand what we are seeing. And that is just a quick little guide on how the eye works.